this. This might help. This is due north. So when we say things like 42 degrees, 30 minutes, we're talking about this angle theta here. This is 42 degrees, 30 minutes. Okay, so that's that angle theta there. And then the other boat, so this is one boat, and then the other boat is a little bit longer, is 52 degrees, 12 minutes. And what they want us to figure out, and you have two boats here, what they want us to figure out is the distance away from each other, the boats. Okay? When both of them are 25 statute miles away from their starting point. Okay? Does that make sense? So now how would you solve that? It's very similar to the problem we just finished. Does anybody have any ideas? How would I find the length? What does that little green line represent? We just did it. Anybody want to share? Anyone? Nobody? Is that an arc length? Yeah. We have to be careful because if that's an arc length, like there's a short distance, there's a straight path between the two boats, right? So we could find that short distance by using some sort of triangle properties, right? We might make some assumptions about the triangle. We might make some assumptions about the arc length, but the arc length will be a good approximation, wouldn't it? So we're just going to make the assumption that they want us to find the arc length. So the arc length between these 2 points, in other words, we want to think of it like this. This is like a circle, right? And we have one boat here. Whoops. Basically, we have one boat here, and we have another boat here. And they want us to find this length here, S. Well, in order to find S, we know that the radius of the circle is 25 miles, but we don't know what theta is, right? So we have to remember that the arc length is equal to the radians times the angle theta between the two rays. Okay, does that make sense? But what do we know about theta? And for this formula, theta always has to be what? No? What does it have to be? It has to be in radians. Did they give us the angles in radians? No. So one thing we could do, first, do you guys agree that we have to find the difference of these two? So I have like 52 degrees, right? 12 minutes minus 42 degrees, 30 minutes. The problem is can I subtract 30 minutes away from 12 minutes? No. So I'm going to have to convert these to decimals. Well, how many minutes are there in a degree? Well, the conversion ratio is 1 degree is equal to 60 minutes. So the first one, what is 12 over 60 reduced down to? In other words, if I were to put in degrees, let's say, here's how you could do it the quick way. You're taking a standardized test. Well, let me show you the long way, and then I'll show you the quick way. So I have 30 minutes, right? But I know that 30 minutes is equal, 1 degree is equal to 60 minutes. So really I have 30 out of 60 minutes, right? if I want to think in terms of degrees. So what's that? 0.5. Where that comes from is I have 12 minutes, or I'm sorry, I have 30 minutes, and I want to convert that to degrees. Well, when I do it that way, the degrees cancel out, or I'm sorry, the minutes cancel out, and I'm left with the degree. The way that I get the number is 30 divided by 60. So this bottom one is minus 42, oops, 42.5 degrees. Because the 42 doesn't change, those are whole degrees. I'm just converting the minutes. So now I've got to do the same thing with the 12. So what I need to do, whoops, I need to come over here and say, well, what are 12 minutes if I convert them to degrees? Well, it's 12 divided by 60, which should be 0.2, but let's check. 12 divided by 60 is 0.2, right? Because it's 1 over 5, and then you double it to get the tenths, right? So 0.2. So then this becomes 52.2 degrees. Now I could subtract those, and I'll do it on the calculator. So I have 52, was it 52? Yeah, 52.2 minus 42.2. So 52.2 minus 42.5 is 9.7 degrees. So our angle theta, the difference between all these things right here, this angle right here, is 9.7 degrees. But in order to do my standing room only formula...
Okay, Junior, it's time for you to go over to church now for confessions. Junior, please go over to confessions now for... Go over to math for confessions.
All right, so now I need to convert that. In order for this to work for this formula, I need my degrees to be in radians, okay? So in order to make my degrees in radians, what I need to do is just convert 9.2 degrees, or 9.7 degrees into radians. So one more conversion and then I'm done. 9.7 degrees times, I want it in radians, so 1 pi radians is equal to 180 degrees. All right, so on my calculator, what I need to do is do 9.7 times pi divided by 180. Now, I would like to write it as pi. So if I wanted to write it as pi, I could say 9.7 divided by 180. Doesn't really help a whole lot. Well, what was my goal? My goal was to get it written in terms of the sublength, or the subarc, or the arc length, I'm sorry. So I want to get the arc length. So I'm going to take 25 and multiply it by a radian measure. Now in this case, if I want to leave it as a decimal, because it's not real nice and clean. 97, if I remember correctly, is a prime number. So there's no easy way to reduce 9.7 and reduce 180. So we're going to get a decimal no matter what. So I'm going to multiply that by 0.169, let's go one more decimal, 1693. Okay, that's what my arc length is going to be. So if I plug that in my calculator, I say 25 times 0.1693, I get 4.2325 miles, 4.23 miles. So that is my arc length. So the distance from here to here is 4.23 miles. And that's exactly what it says. That's what the answer in the back of the book says. Does anybody have any questions about that? Does that make sense?